Hi, in this video we'll talk about how to take derivatives of exponents with a base other than e and how to take derivatives of logarithms that are not the natural log. In other words, a base different than e. So I have our general rules written up here. In general, the derivative of a to the u is equal to the natural log of a to the u, and then du dx. And the derivative of log base a of u, this isn't a to the u, this is log base a u, is equal to 1 over the natural log of a times u, all in the denominator, times du dx. So let's do two examples, and I have two additional ones. In our first example here, we have y equals 5 raised to the minus 4x power. And that looks very similar to this rule right here. In this case, I'm going to let my u be minus 4x, and my du will be minus 4. So when I integrate this, I'm going to follow this rule. So the derivative of y is going to be the natural log of a, which is my base here. In other words, the number I'm raising to a power, so it's 5. Okay, times a, which in this case a was 5 to the minus 4x. Okay, and then times du dx, and in this case du is negative 4. So I'm going to multiply all those things together. Right. I can simplify this further. Negative 4 natural log of 5, I can just write minus 4 natural log of 5. Notice that I can make this exponent positive by moving it to the denominator, so I have 5 raised to the 4x. And then I have one more thing I can simplify. My numerator is going to be minus 4 natural log 5. But down here, 4 to the 5th is 625, so I can write this 625 raised to the x. So that would be my answer. Here's the second example. Some of our rules that we've used up until now have not gone away. For example, in this one, we're going to have to take use the chain rule to find the derivative of g of t. So in this case, I'm going to take 1 as is, which is t squared, derivative of 2. But now remember, 2 to the t is just going to be natural log of my base, which is 2, times 2 to the t. And then I would take the derivative of t, which is just 1. And now it's going to be plus the second thing as is, which is 2t, times the derivative of the first, which is the first thing is t squared, so the derivative is going to be 2t. Okay, and now I can simplify that a little bit. Notice that out of each term I can pull out a 2t, got one there, got one there. I can also pull out a t, got one there, got 2 there. Okay, and so I'd be left with 2t times t, and what I'm left with is natural log, or I'm sorry, t, because I pulled out one of these, I'm left with a t, natural log 2 plus 1. I pulled everything out here, so that's the 1. Obviously, you could have written t 2 to the t power similarly. Let's do 2 more examples, maybe not quite as simple. Okay. So in this example, again, I've got in this example, now I'm taking the derivative of a log, okay, whereas before I was taking the derivative of an exponential. So in this first example, I want to find the derivative of log base 3. So I'm going to find y prime, okay. Now if I go back and look at what my rules are, all right, the derivative of log base a u is equal to 1 over natural log a u du dx. So I'm using this rule right here. All right. So in this example, my a is going to be 3. That's this base here. And my u is going to be x squared minus 3x. And I'm going to go ahead and figure out what the derivative of that is. It would be 2x minus 3. Okay, so I'm going to use all that information, and now using that rule we just talked about is equal to 1 over the natural log of a, so that's going to be the natural log of 3, and then times my u, which is x squared minus 3x, and now all of that is going to be times the derivative of u, which would be 2x minus 3. I can write that as the derivative being, I can just stick this. This is times this whole thing here, okay? So I can rewrite this as 2x minus 3 in my numerator over natural log 3 x squared minus 3x. Okay? And now one final example here. F of x equals log base 2 of the cube root of 2x plus 1. Now recall that since I'm dealing with logs, I can rewrite this log using properties of logs. So this is going to be, since this is an exponent here, I can rewrite it. Remember, the cube root is like writing it as an exponent 1/3, so I can pull that out front. 1/3 log base 2, and now 2x plus 1. Okay, and so now in this case, my 1/3 can come out front. I can essentially ignore it. My a is going to be 2. My u is going to be 2x plus 1, and then my derivative of that is going to be simply 2. Using the same formula I did before, f prime of x, I've got my 1/3. It's a constant, so I can just pull it out front. And now I'm going to take the derivative of this whole thing. Remember that it was 1 over the natural log of a, which is the natural log of 2, times my u, which is 2x plus 1. Okay, and now this whole thing is times my derivative, which would be 2. So writing this in simplest form, okay, I've got a 2 in my numerator, and then everything else is just going to end up in the denominator. I'd end up with 2x plus 1. I guess I could multiply that through if I wanted. Natural log 2. Okay, so those were some examples on how to take derivatives of exponentials when we have a base other than the natural log or e, and how to take logarithms with a different base as well.